Hi, this is Jeff Spence, your Math 135 instructor for the Community College of Denver, and this is our video lecture over Section 5.4, which concludes our unit over probability. So we're going to look at conditional probability and the general multiplication rule here for events that are dependent. So 5.3 was really all about distinguishing between independence and dependence and finding probabilities of independent events where we multiply the probability of each successive event. So this is going to be similar except for the probabilities are going to be dependent. So we're going to compute conditional probabilities and then compute probabilities using the general multiplication rule. So conditional probability, what do we mean by that? Well, we see this notation here. It says P, the probability of F, and then a vertical bar E. So what that says is, it says the probability of F, the event F, given the event E has already occurred. All right, so this is when we talk about dependent events. If a previous event, if the occurrence of that event has occurred and it changes the probability of F, then we want to know what this conditional probability of F is now, given that E has already happened. So it says, suppose that a single six-sided die is rolled. What is the probability that that die comes up before? Well, if we just roll a die, what's the probability that we come up with a 4? That's just 1 out of 6. 1 out of 6. All right. Now, it says, now suppose that the die is rolled a second time, but we are told that the outcome will be an even number. All right. So for some reason, you know that the roll is going to be an even number. What is the probability that the die will be a 4, given that you already know it's an even number? So these are the two events. If we know it's an even number, then we're looking at the probability, or sorry, the sample space that the die could be a 2, 4, or a 6. Those are the three even numbers from a die. So we know it's going to be even, and the occurrence of that event will change the probability that that die comes up before, because now if we know it's even and we want to know the probability that it's a 4, we're looking at the 1 event out of 3 now. These probabilities are different. So knowing that knowing that the first number is an even number clearly is dependent, or rolling a 4 is clearly dependent upon that fact that you know it's an even number. The probability has changed. These are dependent. Okay, we'll have this formula, but the main side that we're going to use is the number of ways that you can get E and F divided by the number of ways E. So if we want to know the probability of F given E, we'll divide it by the number of ways that you can get E, and the numerator will be the number of ways we can get E and F. So let's look at this table here. Okay, and people were asked from what region they lived in, and if they believed in God, believed in a universal spirit, or didn't believe in either. And then the numbers were broken down by regions in the country. Okay, so it says, what is the probability? Let's say, oh yeah, the total is, we surveyed 1,017 adult Americans. So the first question says, what is the probability that a randomly selected adult who lives in the East believes in God? Well, here's the thing. This is a conditional probability because we know the person lives in the East. They live in the East, and we want to know what's the probability that they believe in God. So, of the people that live in the East, we add 204, 36, and 15. Out of those people that live in the East, the total number, 204 believe in God. So the probability will be the 204 divided by the total number of people that live in the East. So we know that they live in the East. That's the given occurrence or given event. So we're going to figure out the sum, the number of people that live in the East, which is 204 plus 36 plus 15. And that number should be 255. 204 divided by 255 gives us the 0.8 probability, or 80% probability. All right, now the next one, the second question. What is the probability that a randomly selected adult American who believes in God lives in the East? So we're flipping the events. Now we know that they believe in God, so we're looking at the total number of people that believe in God. What's the probability that anybody who believes in God lives out in the East? So here We divide by the total number of people that believe in God, which is 204 plus 212 plus 219 plus 152. I don't have that sum off the top of my head. And we're going to take 204 divided by that total, and that is 0.26 or 26%. Notice it's very different from the probability before because it's based on what is the event that's given first. All right, and whatever event is given first, then we take the sum of that and divide the characteristic divided by that sum. So we also can compute probabilities using the general addition multiplication rule, which I have better examples. The examples in this lecture slide aren't very good. So watch my examples video, the 5.3.4 examples, and we'll check you then.